Hello everyone. In this lesson, we are going to learn about continuity of function at a certain point. So here we will be illustrating or determining if the function is continuous or not at that given number. Okay? So when can we say that a function is continuous or not at a certain point? So intuitively, we can say that a function is continuous if there is no holes, no gaps, no breaks on the graph of the function. Ibig sabihin, if you are going to trace the graph of the function, you will never lift your pen. Okay? Now, para mas maintindihan, let's consider the graph of the function below and determine whether the function is continuous or not at x equal to -2, 0, 3, and 4. So this is the graph of the function. At x equal to -2, so this is -2, you can see here that if you are going to trace the graph of the function passing through x equal to -2, you will never lift your pen. So madadaanan mo talaga yung graph ng function. So in that case, we can say that the function is continuous at x equal to -2. Now, how about at x equal to 0? So this is 0 here. Now, if you are going to trace the graph, you can see that makakadaan ka sa isang hole. So therefore, malilift natin yung pen natin. So in that case, the function is no longer continuous at x equal to 0. So we say that the function is discontinuous at x equal to 0. Right? Now, how about at x equal to 3? So this is x equal to 3. You can see here that if you are going to um, trace the graph, there is a break. So mag-stop ka dito, then you will continue here. So from that, there is already a break. So in that case, we cannot say that the function is continuous. So therefore, at x equal to 3, the function is discontinuous. Okay? And how about at x equal to 4? So this is x equal to 4. As you can see, if you are going to trace the graph passing through x equal to 4, there is no holes, gaps, or breaks na madadaanan. So in that case, we can say that the function is continuous at x equal to 4. So this is the case when the graph of the function is given. Now, how about if the graph of the function is not given? When can we say that a function is continuous or not at that certain point? Okay, so therefore, we have here the definition. So this is the mathematical definition of a continuous function at a given point. So we have here, a function f of x is said to be continuous at x equal to c if the following conditions are satisfied. First, f of c exists, meaning f of c is defined. Whenever we are going to substitute the value of c to your function, there is a certain value na lalabas or defined yung function natin. Letter B, the limit of f of x as x approaches c exists. So meron siyang limit, may number. And lastly, dapat yung value ng function is equal to the limit of f of x as x approaches c. So whenever the value of the function and the limit of the function are equal, then we can say that the function is continuous at x equal to c. If at least one of these conditions is not met or not satisfied, f is said to be discontinuous at x equal to c. Okay? So yung tatlong conditions na to ang ating i-check. First, the value of the function is defined. Second, the limit exists. And the third one, the value and the limit are the same. Okay? Para mas maintindihan, let's consider these illustrations. First, consider the function f of x equal to 1 plus 2x. Is the function continuous at x equal to 1? Again, to know that the function is continuous at a certain value of x, we need to satisfy the given three conditions first. So let's check if the value of the function is defined at x equal to 1. So for a, let's check f of 1. Okay, so we will substitute 1 to x. So what will happen here, we will have 1 plus 2 times 1, and this is equal to 3. Therefore, the first condition is satisfied. The value of the function exists, and that is equal to 3. How about for the limit of the function? So let's check the limit of 1 plus 2x as x approaches 1. Okay, so this is our function, 1 plus 2x. And so we will check if the limit exists as x approaches 1. 1 plus 2x is a polynomial function. Therefore, we can do direct substitution. So we will have 1 plus 2 times 1, and that is also equal to 3. Okay, for letter C, we have f of 1 is equal to the limit of 1 plus 2x as x approaches 1. That is equal to 3. Both are equal to 3. Therefore, the third condition is satisfied. Since all the conditions are satisfied here, we conclude that f is continuous at x equal to 1. Okay? So therefore, we have concluded that the function is continuous at x equal to 1. So it is important that you mention the value of x. Kasi at a certain point, pwede siyang continuous or hindi. So you need to specify this value of x. So in this case, we have x equal to 1. Okay? Now, if we are going to check the graph of this function, ito yung graph niya. So as you can see, if you are going to trace the graph passing through x equal to 1, wala kang madadaan ng holes, gaps, or breaks. So in that case, the function is really continuous at x equal to 1. Okay? Now, how about at this example? Suppose we are going to consider f of x equal to x squared plus x minus 6 all over x minus 2. Is the function continuous at x equal to 2? So let's check the three conditions. First one, the value of the function at x equal to 2. So we have f of 2, and that is equal to, all x's here will become 2, so we have 2 squared plus 2 minus 6 all over 2 minus 2. So in this case, we will have 0 over 0. And take note, 0 over 0 is indeterminate. So therefore, the value of the function at x equal to 2 does not exist. And since one condition is already violated, we can already conclude that, so at least one of the conditions yung mapapakita nating hindi na satisfy, automatic we can conclude that the function f is discontinuous at x equal to 2. So that's it. Now let's check the graph of this function. So as you can see, if you are going to trace the graph, there is a hole at x equal to 2. That's why the function is discontinuous at x equal to 2. Okay? Now how about this function? We have f of x equal to square root of x minus 3. Is the function continuous at x equal to 3? Let's check the three conditions. First, f of 3. And we have square root of 3 minus 3, and this is equal to square root of 0. Take note, we are not yet solving the limit. So therefore, square root of 0 is 0. Okay, so it exists, and that is equal to 0. Next, letter B. Limit of f of x as x approaches 3. And we have limit of f of x here is square root of x minus 3 as x approaches 3. Since this is a radical expression or radical function, we can substitute. So we have square root of 3 minus 3. Now take note, we are solving for the limit. So we need to check the index of the radical sign or radical expression. So in this case, our index is 2. There is an imaginary 2 here. So in that case, yung nasa loob should be greater than 0. Right? So therefore, since this one is square root of 0, we can conclude that the limit of square root of x minus 3 as x approaches 3 does not exist. Okay? So that is our conclusion for step 2. And since step 2 is already violated, we can say that f is discontinuous at x equal to 3. Okay? Now let's look at the graph of the function. There. So as you can see, if we are going to trace the graph, there is no graph sa left side. So wala tayong matitrace. So in that case, we say that the function is really discontinuous kasi walang graph sa left side ng x equal to 3. Okay? Now for the last example, suppose we are going to consider a piecewise function. F of x equal to x plus 1 when x is less than 4, or the quantity x minus 4 squared plus 3 when x is greater than or equal to 4. Let us check if the function is continuous at x equal to 4. So for letter A, let's check if the function is defined. So we will have f of 4. Now let's check since this is a piecewise function, saan nabibilang yung 4. So 4 belongs to this interval when x is greater than or equal to 4. Therefore, we will evaluate the function sa second sub-function niya. And that is x minus 4 quantity square plus 3. So doon natin siya i-substitute. So we will have 4 minus 4 squared plus 3. And this is 0 plus 3, so we have 3. Therefore, the value of the function is defined at x equal to 4, and that is equal to 3. Okay? Let's try letter B, the limit. Now, in this case, since we have a piecewise function, so in evaluating the limit, we need to consider the function sa left side ng 4 at sa right side ng 4. Kasi dalawang function ito, right? So in this case, we will solve for the one-sided limits. So let us check first the limit of f of x as x approaches 4 from the left. Now, from the left of 4, those are values less than 4. Therefore, we will use the first sub-function. So in this case, we will replace f of x by x plus 1 as x approaches 4 from the left. And since x plus 1 is a polynomial function, we can substitute directly. And we will have 4 plus 1, and that is equal to 5. So the left-hand limit is equal to 5. How about the right-hand limit? So we will have the limit of f of x as x approaches 4 from the right. So in this case, we will have the limit of, since from the right of 4, those are values greater than 4, we will use the second sub-function. So we will have the quantity x minus 4 squared plus 3 as x approaches 4 from the right. And since again this is a polynomial function, we can substitute directly. So we have 4 minus 4 squared plus 3. And this is equal to 3. And since the left-hand limit and the right-hand limit are not equal, we can conclude that the limit of f of x as x approaches 4 does not exist. So as a whole, the limit does not exist as x approaches 4. And since the second condition is not satisfied, we can conclude, therefore, f is discontinuous at x equal to 4. Okay? And looking at the graph we have here, so makikita natin when we are going to trace the graph, there is already a break here at x equal to 4. Therefore, it is discontinuous at x equal to 4. Okay? So that's it for this lesson. I hope you have learned something. Thank you for watching.